All right, hello students. We're looking at 10.3 today, multiplying binomials, which is going to be two of these different binomials being multiplied by each other. We'll see some polynomials later, but for now, there's a couple ways we can look at this. All right. So first of all, the way that I like to look at it is down here in that words description. Okay. There's an acronym we have for this. It's called FOIL. F is for first terms, O is for outer terms, I is for inner terms, and L is for last terms. First, outer, inner, last. So you might hear me say that a little bit. Really, this is just the distributive property happening multiple times. As you can see up here in orange, we first have the x being multiplied by the entire second binomial, and then we have the -2 being multiplied by the entire second binomial. So really it's just the distributive property happening twice, but this FOIL explanation kind of has us keep a specific order to it so that we maintain that same process over and over. Okay? Now once you get that distributive property done, once you've distributed both terms, you're likely going to end up with two like terms to combine. The last step is to combine those terms, and you're left with your fully simplified, in this terms, trinomial. Okay, so there's a good explanation here on the front page. They have it illustrated there with colors. They show all of the multiplications from left to right. So there's really two ways you can go about this. There's that FOIL method, what I like to call it. Okay, you've got the x minus 1 times x plus 7, where we're going to go through in order. First is going to be that x times x, which is going to be x squared. Okay, you've got that x times x, that'll give you x squared. And then you've got your outside, so we're going to take that first term in the first binomial and multiply it by the second piece, the two outside terms. So you have x times 7, which is going to be 7x. Then we're going to do the inside terms, -1 times x. So those two terms on the inside, which really is the second term in the first binomial, starting its distribution. So -1 times x is just going to be -x, okay, or -1x. And then you've got -1 times 7, which is those last terms, the second term in each binomial. -1 times 7 is going to be -7. Okay, so I've got my four terms. Let me kind of split this here so we can save some room for that second example. So then I'm going to end up with x squared plus 7x minus a single x minus 7 at the end. Remember, we're going to end up with like terms in the middle. Okay, so you're going to end up with, let me get that back over there. You're going to end up with 7x minus x in there. Those are going to combine. Remember, that is technically a -1x, so the x squared stays unharmed. 7x minus x is going to be 6x now. We took one of them away. And then that -7 is going to be brought down as well. So that's what you're going to end up with for your final answer. Now, the box method that a lot of people like, okay, so this one was the FOIL method. And then you're going to see the box method. What the box method is it's really taking a visual approach to this, where you're pretty much doing these same multiplications in a process that's very similar to finding the area of something. So you're going to spread these terms out along the sides of this box. Okay? You're going to take your first term, that x minus 1, and you're going to put x and -1 either on top or the left side of the box. And then you're going to take your second term and split those two terms up, x and +7. So then basically all four of your multiplications are the four different regions of this box. Okay? So for this first one, you've got x times x, which is going to be x squared in that first box. Then for this box here, for the -1, it's got the -1 along the top and the x along the side of the left. So it's x times -1, which is going to be -x. Then you've got this x on top and 7 on the bottom. X times 7 is going to be 7x. And then you're going to have the -1 along the top and the 7 on that bottom left. -1 times 7 will be -7. And then you're just combining any like terms that you have. And if you can see in here, you're going to end up with like terms in those diagonal boxes. Okay, so you have an x squared term that's all by itself. You have 7x minus an x will give you 6x. And then that -7 is all by itself with no like terms as well. And you end up with the same exact answer. So there's two methods to this. Okay, you can do that either way. So again here, let's try the box method here. So you've got 3x and -4 along the top. Doesn't matter which one you put on the top or the side. And then 4x minus 10 along the left. Okay, so first box, you're going to have 3x times 4x. That's going to be 4 times 3 is 12. X times x is x squared. -4 times 4x in here. You're going to have -4 times 4 is -16. And then there's just one x being brought along in that multiplication. 3x times -10. 3 times -10 is -30, and there's just one x involved there. And then -4 times -10 is going to be a +40. You combine your like terms, okay, which is going to be -16x and the -30x, and we are left with a 12x squared, which doesn't have any like terms, -30x minus 16 more x is going to give you -46x. And then that 40, +40 all alone in the bottom right-hand corner does not have any like terms to combine it with. So that would be your final answer. Okay? Here, some more examples. We'll look at these in that FOIL pattern. Okay, so first is x times 4x. That's going to be 4x squared. Outsides is going to be x times a -8, so I'll have -8x. Insides will be 7 times 4x. Let me draw that up here. 7 times 4x, that's going to be a +28x. 7 times 4 is 28, and there's just one x involved. And then last is going to be that 7 times -8, which is going to be -56. Your last step is to combine any like terms. -8x plus 28x, so -8 plus 28 is going to come out to be a +20. It's the same as 28 minus 8. So you've got the 4x squared coming down, a +20x, and the -56 coming down. And this is just the same process over and over. Okay? First here, 2a times 5a. 2 times 5 is 10. A times a is a squared, so we have 10a squared. Get some different colors in here this time. 2a times 3. 2 times 3 is going to be 6, and then there's just that a along for the ride, so we've got 6a. Then that second term now, the inside multiplications, -12 times 5a. -12 times 5 is going to be -60. So we have -60a. And then we've got -12 times a +3, which is going to be -36. Okay? Again, you go ahead and you combine all of your like terms, which is just going to be those middle terms here. Okay? So 10a squared is coming down. That's not harmed. 6 minus 60 is going to be -54. So we have -54a. And then minus 36 at the end, that was untouched as well. And that would be your final answer. Okay? Now you might get some word problems in here. A town worker is clearing the snow from a parking lot and the surrounding sidewalk. The sidewalk extends X feet on every side of the parking lot. Write an expression for the total area. So you only need to write the expression here. We don't need to see the solution over and over. But what you're seeing here, you've got this square, okay? So we know this much. We know that this square has an exact measurement to it. It has a number measurement. Okay, so this much is going to be 70 feet. And then down here, it's 60 feet across. Now, if it's extended by x on all sides, what we need to be careful about, okay, so this portion is 60, and this portion is 70. Now, where we usually make the mistakes in a situation like this, okay, for the most part, most of us could say that, okay, that's x, so I'm going to have 60 plus x. But be careful, because there's one of these extensions on both sides. So there's actually that extra space of x happening twice on both the length and the width. So for the full width of it, we've got 2x plus 60. You could put 60 plus 2x as well. It doesn't really matter. And then for the full length, okay, again, I've got my 1x up here, and I've also got x down here. So then for the full height of this, I end up with 70 plus 2x, or 2x plus 70. It doesn't matter what order you write them in. And then this would be where you would multiply all that to find the area of that parking lot. Okay? So for the word problem, we'll just set it up and we'll leave it there. We won't solve that. But you would set that up like that, where you are making sure you're accounting for all the sides and all the extra bits off of each side. And now our last set of examples is where you might see something with more than 2 terms in them. These aren't all going to be binomials. So now the whole FOIL acronym doesn't really work, which is why a lot of people kind of like to stay away from FOIL. But the same principle as FOIL does apply. Okay? You're going to take this first term x and make sure it is being distributed to every piece in the back. So I've got x times x squared, which is going to be x to the 3rd power. That's coming from our module 8 rules. I've got x times a negative x, okay, which is just going to be a negative x squared. It's like having a negative 1 in front there. And then x times a negative 9, which is just going to be negative 9x. Okay? Then I'm going to take that second term, that 3, and I'm going to make sure that distributes to everything in the back. So I've got 3 times x squared, which is just 3x squared. Nothing fancy about that. 3 times a negative x. I have to make sure that's a negative 3x. It's like I have a negative 1 in front of that second x. And then 3 times negative 9. And that's just going to be negative 27. So if I wrote all these out, okay, I've got x cubed minus x squared minus 9x plus a 3x squared minus 3x minus 27. That's all my terms from left to right. Now I need to combine the like terms. Okay? So I need to make sure that I'm combining all of my like terms. I have 2x squared terms. There's one right here and one right here. Okay? And then I have 2x terms. There's a negative 9x, negative 3x. So remember to keep this in standard form with the highest exponent first. Let's write these down in order. So that x cubed doesn't have any like terms. It's just going to stay x cubed. The x squared needs to be combined with the 3x squared. So I have a negative x squared and a positive 3x squared. That's really just negative 1 plus 3. Negative 1 plus 3 is going to be a positive 2x squared. A negative 9x and a negative 3x. So negative 9 minus 3 more is going to give me negative 12x. And then that negative 27 is not going to be combined with anything as well. And that's going to be my final answer. Okay, now I only have like 40 seconds left, so I'm just going to do this last one quickly, and then you guys can kind of use it to pause with the notes. So 3 times 4, I've got 12t to the 4th, because t squared times t squared. 3t squared times a negative 4t, I'm going to end up with negative 12t to the 3rd. And then 3t squared times 14 is going to give me 28, 42. So I end up with plus 42t squared. And then I've got negative 5t times a negative 4t. I can see I'm going to run out of time with this example. Okay? So the rest of this example will be on the notes. And then that is it for this 10.3 video. Check the notes for that full last example.